Hello everyone, I am Professor Ken Maksore. In this today's session, we are going to study the different follower motions. We have the total four follower motions in our syllabus. One is the uniform velocity, second one is the uniform acceleration retardation, third one is the cycloidal motion and the simple harmonic motion. In this today's session, we are going to focus on the uniform velocity, which is one of the simplest form, which is easy to that um, design and easy to draw. And we are in this session also we are going to study the mathematical modeling of the uniform velocity. The objective of this session to aware about this displacement diagram for the uniform velocity and its mathematical modeling, and with this you can design the that simplest form for the any particular application where we required this motion for the low speed application, and you can design this design the cam and follower according to this session. Now in this, while drawing or while studying its mathematical modeling, we need to consider some nomenclature. S, which is the stroke length, omega, which is the angular velocity of the cam, theta is the cam angle, theta O is the outstroke angle, theta DO dwell after outstroke, theta R return stroke angle, and theta dr dwell after the return stroke. That means we are going to draw the rise, dwell, return, dwell type of cam. Now I'll just give the overview of this mathematical modeling. Okay, in this case, first of all, x, which is the displacement, or this is the equation for the this displacement diagram. In this case, x, which is the displacement of the follower, for any particular cam rotation. If you put this theta over here, you can find the value of x. Now theta o, which is the outstroke angle for this particular range, this is the theta o, which is the outstroke angle, and this is the total stroke, which is the s, which is the stroke length. By putting the value of theta, you can find out the value of x. If you differentiate this equation, you will find the equation of the velocity, which is of v is equal to omega upon theta o into the stroke length. Okay, in this case you will find nothing is the variable in this case. Omega is constant, theta o is constant, and s is constant. By using this, you will find out this is the equation of the this is the you will find the straight line, and this is the equation of the or this profile, which is the uniform velocity. That velocity is constant. Okay, again if you differentiate this, for the constant there is a sudden rise over here. If you differentiate this, we will find out the infinity. For this particular range, if you differentiate this, you will find the 0. That means if we differentiate this equation, that acceleration which gives the infinite jerk at the start, that's why this that follower motion, which is not recommended for the high speed application because of its infinity in nature during its acceleration. Okay, now this is the mathematical modeling. Now we'll move to the graphical method, how to draw this that uniform velocity motion, or how to draw the follower displacement diagram. Now in this case, first of all, you have to consider one coordinate system, or you have to draw one horizontal line. The total length of this horizontal line should be the 180 mm. This is one simplest method. Just try to understand this. Just consider horizontal line which is of 180 mm or the 18 centimeter, which denotes the cam angle of 360 degrees. Now draw one vertical line which length is equal to stroke length. This is the blue line, stroke length. Next, after drawing this horizontal and vertical line, that means stroke length and the cam angle, we need to divide this total cam angle into the four parts, in which theta o is equal to 60 mm, theta do which is of 20 mm, theta r which is the return stroke which is of 60 mm, theta dr is of 20 mm. Irrespective of any angle for the theta o, theta do, theta r and the theta dr, we need to take the same dimensions while dividing. This theta o is of 60 mm, theta do is of 20 mm, theta r is of 60 mm, and theta dr is of 40 mm. Next, now suppose in this case that theta O, theta DO, theta R and theta DR, which are given 120 degrees, 30 degrees, 90 degrees, 120 degrees, irrespective of any angle, you have to take this distance is equal to 60 mm, 20 mm, 60 mm and the 40 mm. Now we have to draw the vertical lines for the theta O, theta DO, theta R and the theta DR. This total vertical line, this must be equal to the stroke length. Again, in this case, no need to, don't take any scale for this. Suppose this value is of 50 mm, we have to draw the vertical length of the 50 mm only. Don't take any scale for this. Next, you have to divide this theta O and theta R into the 6 equal parts. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Which is of 10 mm, 10 mm, 10 mm, 10 mm, because this total distance is of 60 mm. This total distance of 60 mm. For theta R, this distance is of 60 mm. That's why we can divide into the 6 equal parts. Now we have to give the numbering 0, 1, 2, 3, 4 for these 6, 6, 12 equal parts. You have to start from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and last number should be the 14. Next, you have to draw the vertical lines which are equal to the stroke length. That lines must be parallel to this stroke line, that first initial line. In this way, we have to draw the vertical lines. Next, you have to draw one diagonal line for this theta O. Again, this diagonal line which intersects that these equal parts which intersects this diagonal line at this point, this point, this point. You have to mark these points and you have to give the names, that means notation, which starts from the A, B, C, D, E, F, just like this. Again, you have to draw the horizontal line over here. And the same procedure we need to follow during the return stroke. You have to draw this diagonal line and you have to mark these vertical lines that you will get the intersection points. Again, you have to continue this horizontal line for the dual period G, H, I, J, K, L, M. Again, you have to draw the horizontal line for this dual stroke. Okay, 13 to 14. And in this way, you will get the total displacement diagram for the uniform velocity. Now you have to take these distances 1a, 2b, 3c while drawing the cam profile. With this, I will finish my session over here. Thank you for patience listening. In this lecture, we have started with the mathematical modeling and with the graphical method of this uniform velocity. Thank you for your patience listening. Thank you.